Hello everyone, this is R.Arivazhagan from Agni College of Technology. Today we are going to see about the topic electronic ignition system from the subject automotive mechatronics. Let's start. Electronic ignition systems. We all know what you mean by ignition systems. So usually the ignition systems will be present in petrol engines. In petrol, the auto ignition temperature was much higher, so the fuel will not burn automatically. Why? Because the auto ignition temperature of petrol is 550 degrees centigrade, where at the end of the combustion stroke, we may not reach that temperature for automatic burning of the petrol. Whereas in diesel, the auto ignition temperature was slightly lower, around 450 degrees centigrade. So we don't need any sort of ignition systems in diesel engines. But petrol engines, since the auto ignition temperature was much higher, we need an ignition systems. So there are several ignition systems have been used in various automotives. The first one was mechanical ignition system. Next, we went for battery ignition systems, and then capacitor ignition systems, then electronic ignition systems, and then programmed ignition systems, and then direct ignition systems, and then distributorless ignition systems. So there are several ignition systems were available. Now today we are going to see about the electronic ignition systems. So it uses the electronic control module. Here you can see this is the electronic control module. So basically the principle behind the ignition system is the magnetic flux collapsed inside the ignition coil. So this was the basic principle used in all the ignition systems. Here also the same principle is applied. So let's go deep into this electronic ignition systems. Okay. So usually let us see first the various components of this electronic ignition systems. So the first main component is battery. So the next one is ignition switch. The next one is electronic control module. The next one is ignition coil. The next one is distributor and then spark plug. Here we are going to use the magnetic pickup, armature or reactor and vacuum advance. Let us see the various functions of these components. Battery. So the battery sends a 12 volt DC current to the electronic control module. So via ignition switch. So whenever an ignition switch is on, the 12 volt battery current flows from battery to ignition control module and then to the ignition coil. The ignition coil consists of primary and secondary coils. So the 12 volt current passes through the primary coil of the ignition coil. Then the same current will pass through the distributor and through the spark plug. But now the spark will not be generated as there is no magnetic flux collapse inside the ignition coil. So, since the spark plug was kept inside an high compression engine chamber, we can't that 12 volt is not enough to produce the spark plug. We need high voltage to produce spark plug inside the cylinder. So, in order to achieve this, we have to collapse the magnetic flux inside the ignition coil. So, for that, an impulse from the magnetic pickup and armature or reactor has to reach the electronic control module. The electronic control module consists of diodes, capacitors, and other programmed systems that was being embedded and kept pre-programmed within this electronic control module. So whenever the impulse comes from the magnetic pickup and armature or reactor, the electronic control module passes the voltage that passing through into the ignition coil for a second. So within that 1 second, the electronic control module pass the current and send the current again. So due to this, a magnetic flux is collapsed inside the ignition coil. So due to the collapse in the magnetic flux in the primary coil, and a high voltage is created in the secondary coil. So this high voltage and then pass through the distributor. Now the spark comes. So the main reason is this impulse and the electronic control module, so which can be controlled electronically. Here the spark is controlled by means of this pre-programmed electronic control module by means of this armature or reactor magnetic pickup, and the vacuum advance uses or measures the vacuum from in the inlet manifold and sends this signal to the electronic control module. So by using the data from the armature or reactor, magnetic pickup and vacuum advance, this system produces an impulse to electronic control module. So the electronic control module passes the current, that is voltage, to the ignition coil for a second in order to create this magnetic collapse. So this armature or reactor magnetic pickup will be as act as a sensors for sending the impulse. So this is pre-programmed according to the ignition timing. Now we are going to see a small animation of the electronic ignition system. Let's dive into electronic ignition system. So previously we used mechanical ignition system where contact breaker points has been replaced by electronic ignition module. In electronic ignition system, breaker points are replaced by electronic ignition module. So armature sends signals to ignition control module and make and break the circuit. So here, this is the basic principle, that is when ignition key is switched on, the current flows from ignition module to the distributor. Now, the reactor or armature and the pickup coil generates voltage signal and sent to ignition control module. So, the electronic control module senses the signal produced by the pickup coil and stops the current to flow from primary circuit. So, as I said earlier, this creates an magnetic flux collapse. So the timing circuit inside the ignition module turns on the flow again when the reactor tooth rotates away from the pickup coil. So due to this continuous make and break of the current, a high voltage is generated and that is sent through secondary coil to the distributor and the spark is generated. So the distributor decides So which cylinder has to be fired? So this was the basic working of electronic ignition systems. Thank you.